So, can we switch to the right screen? That would be nice. So, the thing is, when we're in Germany, for some reason, German people like always want to talk about football and how Netherlands never became like Weltmeister. So, to counter that, and then I don't want to hear anything about it anymore later at the beer garden, I got a German joke. Was macht ein Hollander, wenn Weltmeister Fußball wird? Schaltet seine PlayStation aus. So. Okay, thanks. Now we have that out of the way. As said, I'm Jongboom. You can follow me on Twitter on the left hand. If you have any photos, nice stuff that you do, like today, Vines, I don't know, like please tweet them to me. You know, my mom still gets like super excited if she like sees that kind of stuff. So I've been quoted as an engineer working for Mozilla. That's partially true. Actually, the company that's currently paying me to be on this stage is Telenor. And Telenor is like a big telco, like Deutsche Telekom, 30,000 employees worldwide, and a lot of them have boring, shitty jobs, like working as telecom engineers. I never heard of them, and 2.5 years ago they approached me and they asked me, hey Jan, do you want to work for Mozilla? I'm like, well, yeah, sure, but why do you ask? And they were building a new team, strategic engineering, it's called today, where they wanted to have like a bunch of open source developers like working on various projects. So for the past 2.5 years, they've literally paid me to work on Mozilla things. I hope my manager doesn't see this talk, you know? So it's really fun. I've been working on Firefox OS for like the first 2 years. After that, I switched gears a bit, like trying to find like how Mozilla could go into the Internet of Things space. Like what can we do with connected devices? I've worked on Firefox OS for Raspberry Pi, but also on Mscripten, the C to JavaScript compiler. A variety of projects, but I'm also like interested in general like low-powered wide area networks. So like for a guy like working on Mozilla and working on the web every day, I write an awful lot of C rather than JavaScript. What Telenor asked me to do mostly is like go down to their markets. Like let's say we want to build a phone and launch it in Bangladesh. They put me on a plane and then I do a workshop there with like the local guys, I do trainings, etc. So to get started, I have it's called Spot the Blonde Person. And the question is, can you spot me in this group photo of our latest workshop in Bangladesh? It's kind of hard. Anyway, real fun. Who in this audience does write JavaScript? You know, this is amazing. Like literally, like half the audience or something. The rest is still learning in that sense. Now, the thing is that half of you actually admit to doing JavaScript is an incredible win for me. You know, this was never the case. Like this was me 15 years ago. And back at those days, it was pretty much on this side. And I know that a lot of you have been here, you know? For my first web project, and I'm a bit ashamed to admit it, I did not choose JavaScript, but I actually thought that VBScript was by far a better alternative. And I'm not alone in this. Like still when you talk to about JavaScript, like some people like get some pain and you know, for a reason. For like years, JavaScript was like the laughing stock. The laughing stock of the school. You know, a toy language. But now, look at all these people. Like half the audience that actually admits like we do JavaScript. It's amazing, you know, in the last couple of years, you know, we took our revenge. You know? So I'm real happy about today to talk about JavaScript. JavaScript and like the real world in that sense. So let's think back, like before the mobile revolution started. There was like very limited input methods. Like the only thing you could use is like a mouse and a keyboard to get data in and a screen to get data out. Like kind of lame, you know? These days, we have mobile devices, and they can do way more cool stuff. They have all these sensors. For example, a vibration sensor, you're not going to find it in your computer. Like actually, like vibrating your computer is like a thing you want to avoid, something you're going to ask Yahoo Answers for. Now, the thing is that the web as we see it today, or like a couple of years ago, is never made for this kind of input. When we're talking about mobile web development, and we've seen it a lot, mobile web development is like, oh, I want to make my website responsive. I want to make it like smaller and like make a nicer button. It's not about that. You know, it's about using like all this sensor, all this new technology to avoid users like putting in data. So we can do a lot of stuff with native that for like a long time we could not do with the web. For example, you could not detect this with a web application a couple of years ago. Need an accelerometer to see that falling. Actually, this is one of the sensors, you know? There's like a lot. In an average mobile phone these days coming out, there's proximity, accelerometer, ambient light, magnetometer, gyroscope, humidity, ambient temperature, pressure, battery, cameras, everything, you know? Even the battery of your mobile phone has sensors in it. The two outer pins, that's the power lines. The two inner, data lines. Fun thing, if you have some duct tape, just tape it over the two little metal things on your battery. Phone will still work, just report 0%. Sensors don't work. Now look at this whole list. You know, we almost have everything. Everything to get data out of the real world into our mobile devices. Actually, if I think about it, there's only one sensor that we're missing in this thing, and that's the bend sensor. Good. So Internet of Things. So sensors are becoming cheaper and cheaper and cheaper. And that enables like the whole Internet of Things movement. The reason why I can just like go to my local store in Amsterdam and buy a gyroscope for a few euros is that this whole mobile phones thing happened. You know? Suddenly we need like 1 billion of them, so price goes down. It's pretty nice. And we see some amazing stuff happening with all these sensors. Like look at some of the real life examples that I gathered. On the left, on your right, we have Moves, an application from Facebook, now owned by Facebook. It just sits silently in your pocket, and whatever you do, walking, cycling, driving, it automatically tracks whatever you do. It's like indistinguishable from magic. There's no input required. Or look at instant heart rate. What you do is you put your finger on the camera, it uses the flashlight to light it up, and then checks how the pulses are going and gets your heart rate that way. Or sleep cycle. You put your phone on your mattress, and then automatically detects like how your sleep cycles are going. Normally like this. Tonight, after the beer garden, it's going to be like this. So this is all amazing stuff, like really cool stuff. There's only one big problem. And that is that this kind of stuff is so incredibly boring. You know, it's so incredibly useful. It's all been done before. You know, whatever, we have sensors for 6 years. Why would we like use them this way? You know? It's also functional. Let's step out of that paradigm. Like one of the few apps that came out in like the recent year that got me really excited was an app that let you throw your phone up in the air as high as possible and then post your high score on Facebook. Send me to heaven, it's called. For unclear reasons to me, Apple did not accept this into the App Store. But I get happy about like little developments like this, you know? What we should do as developers is realize that out there, all around us, there's some amazing data available, you know? There's some amazing data available. Let's use that in like an unconventional way. Like, why do I always have the need to buy a Raspberry Pi and like attach some sensors to it and then do some crazy stuff when I also have a phone that already has a whole bunch of these things? So what we're going to look at today is a whole bunch of demos, because I know it's like late and you're tired and you want to drink a beer and, you know, tell me I'm here. This morning I walk into this place and it says like tweet for a beer, and I'm like, yeah, but I have to wait 7 hours before I have a talk. Yeah. I still think they put me at the end because I'm Dutch and I have to like sit here. Okay, so let's look at like a bunch of demo stuff that we can do with your mobile phone in JavaScript. It just runs in your web browser. You know, this is all here at this point. Like cool stuff that we can do today to do it a little bit different with the data coming out of all those sources. Let's look at one of the sensors that's in your phone, the device light sensor. The device light sensor, there's light falling into the sensor. And depending on that, it can adjust the brightness. So when you're sitting in full daylight, your screen gets brighter. If you're asleep at night, it gets like a bit less. Then I thought, if it measures the light falling in, we have influence over that. Because if I block the light with my hand, like less light falls in and I can detect that. The only problem with it is if you're thinking that, you're like basically waving your hands, you know, above phones. But then, I thought about the Big Bang Theory. Because Sheldon is at some point playing an instrument called the theremin, which is a wave that you can then manipulate with your hands, and by doing that you can create music. So what if we can recreate a theremin by using some JavaScript and data coming out of the device light sensor, and feeding that into a tone generator, and that way, by waving your hands, generate some cool music. Totally possible today. What we need is the web audio API and a little bit of code to read the data. It's literally 7 lines. So what we do is create a new audio context. We create an oscillator, which is an object that emits one tone. And then we read the data from the device light sensor and feed it as the frequency value of the oscillator. Manipulating the data, manipulating the frequency, getting sound out of that. That's one. We're gonna see all these demos, you know. The second one. Can be in a commercial. The gyroscope. So one of the real purposes is that it can detect when you flip the phone. Oh no, rotate screen actually. So it measures like the forces being applied to it, the rotation, whatever. It rotates the screen. Now what we can do as well is, because we get like the pitch and the yaw of the phone and how you like hold it in physical space, is that we can use it to track real-life movement on a computer or on another website. A bit like how you're using like a Wiimote. You hold it in your hand and then you do some stuff with that, and then based on that something happens on like the big screen. So if you draw like a 3D model of phones, measure the gyro data, and then map that back to the phones, we suddenly have a model that we can change in the real world, and that will be directly reflected on the screen. So I hacked something up in 3JS, WebGL framework, because a phone is essentially just a box with a nice picture on top of it. Get the data out of the real phones and then manipulate the model on screen. So the first thing that we need to do is set up a box in 3JS, slap like a nice front and a nice back picture on top of it, add it to a scene, and then we can listen for the device orientation API, a web API that gets gyro data, and then map the rotation of the phone directly on top of the sensor values. This is something that you can use in a game or in whatever you're developing. Suddenly a user has like an external remote for your application that he can like actually do stuff with. Third thing, accelerometer. Real purpose, turn to mute. So the idea is that it measures the forces being applied to the phone, the acceleration. So when the phone is like put on the table, it's 9.81 gravity. downwards. But if I flip the phone, then it suddenly becomes negative because the force is being the other way around. So I can easily detect, like it was 9.8 now, and I flip it, now it's minus 9.8, okay. Someone flipped the phone. But if it can measure the C forces, Z forces, then we can also use it to visualize juggling. You know, because in juggling, I'm throwing the phone up in the air, and then it comes down. Gravity pulls it down. So if I plot the Z value in a graph over time, essentially what I get is like a nice juggling visualizer. I know which one is up at what point and when it comes down. When you do this with multiple devices, juggle with phones, get nice visualization. What we need, you're gonna see this all live, man. The people in the other track are gonna be so sorry. So what we do is we listen to the device motion, which detects like the force. We get the value from the z-axis, and then add a new line in our graph. I use any graphing library. So now the first time I did like this talk with examples in a workshop in Hungary, a bunch of guys thought, yeah, but if we can measure the forces being applied on the phone, they can use that to build a weight scale. Like literally, these guys built a JavaScript-based weight scale. They put the phone on a soft surface, then calibrated it, then put like 100 grams of weight on one side, detected how the gyro changed, and now they can put some coins on the side and then like immediately get the weight. You know, this is. If this is not the future, I don't know what is. So actually, we had a discussion about this. Like, first we wanted hoverboards, then flying cars, but actually we just want a drone that can carry a human. You know, way cooler. So we're gonna get to that. No problem. At the end of this presentation, you'll be writing flying cars in JavaScript. So now to like a bit more like practical stuff, like computer-generated music. A lot of the music that we listen to today already gets like partially or fully generated by computers. And if it's not generated, at least the computer helps, for example, by looping your drum track. Some people take this like a little step further, and these guys are called algo ravers. Originally started by a guy named Alex McLean, and yeah, I still can't go over how awesome this is. This is a guy standing in front of the club, like an actual club, with his laptop, like live programming music algorithms and visual algorithms, and there's people dancing to that. You know, if you want any more proof that nerds just won the world, then it's that, you know? People dancing to our algorithms. It's fantastic. And if you want to do this in JavaScript, there's a great library called Jibber. Charlie Robert, a PhD from UCSB, wrote this. And it's essentially a live coding environment for this kind of things. Live coding music and graphical visualizations. So what you get is like a small language where you can define like how your music should sound. So in this case, we have a drums and we give it a pattern. And it sounds like this. Pretty cool. I'm an artist now. We can add variables like some pitch. Or we can like go further and add like vocoding and text and stuff. Or do it like variables, so we get like different thing every time. But if you look at this from like a developer perspective, what you see is essentially a whole bunch of variables here on screen. You know? A pitch, a word cap for like the speak thing. They're variables, they're like variable in essence, and sometimes they're even randomized, like what you can see here. But they're still like thought up by the algo raver in front of the audience. You know, it's kind of sad to give like the artist all the credit in that sense. Then I thought, what else do you see at concerts these days? A whole bunch of phones. And as we said, like a bunch of times before, all these phones have a whole bunch of sensors that we can abuse. You know, a lot of sensors. And if your phone has 10 sensors, and there's 100 people in the audience, then you got 1,000 sensors that you can use. So what if we use all the data from all the sensors, we gather that, we send it off to a Node.js process, IOJS process, and then feed that as parameters into the music. That means that when people interact with their phone in the audience, they can actually influence the music that comes out of the sound system of the DJ. Like, fantastic stuff. So I wrote a little module to do that. And what you get now is you get like a new object that automatically gathers all the data and then creates a new variable out of that. I know you guys are like excited and you want to see this, but got a couple more slides. Then, getting data out of the real world. I mean, everything we still talk about is still really confined into this little box, your phone. We don't really do anything with like the real surroundings. It's just like, oh, I do something with the phone and then something happens. So now let's have the real world send some data to us instead. There's a new thing called Bluetooth beacons, and I got some here as well. This is like the old generation. They're going to get like a lot smaller. But the idea is that you put a beacon and it sticks here on the wall. And it sits there and it broadcasts its existence once a second for like 3 years. Just like, I'm here, I'm here, I'm here, I'm here. And it can broadcast some data like, oh, I'm ID X or ID Y. So they have like a super long battery life. They're pretty cheap. $10 or something if you want to have a retail one, or $3 if you solder it yourself. And it can broadcast some values, like URLs or sensor values, etc. And beacons for me are like fantastic. Because it just sits there, say like, I'm here, I'm here, I'm here. And they can kind of detect like how far they are away from you. So what if like everyone here at DAO had like a beacon on their badge? And they would have an app that sits on your phone just listening in the background on which beacons it saw. Then suddenly at the end of the conference, you know like how close you were to which beacons at which point during the conference. Pretty low power. It's possible today to build, really. Then at the end of the conference, I could just, oh, you talked this long with this person, this long with that person. You want to reconnect? Yes, no. Oh, you saw this talk, you saw that talk. It's fantastic. This is incredible technology, at least for me. And then the cool thing is that it's also coming, it's at the moment in Android 4.3 and up and iOS 7 and up, but it's also coming to a web browser near you today. So suddenly you can also do it from JavaScript. It's actually in Firefox OS today, and we're hoping to bring it to Android anytime soon. Also, the Chrome team is working on it, so it's being standardized in W3C at the moment. So we're going to see this on web browsers, actually. If you want to use it today, this is how you do it. So first of all, we get the adapter. Then we start, it's French, actually. Start le scan. In this case, we don't care what kind of beacons, we want to find all the beacons. Then when a device is found, an event fires, and we can parse the payload. So you basically have 60 bytes to send whatever you want. And at the end, we stop the scan again, after 5 seconds, for example. Now, what can you do with this? Because you can also like read like how much power did the signal still have when it arrived at the phone. We can build a baby monitor, a JavaScript-powered baby monitor. So the idea is to tag your baby with a phone, then put 3 beacons around the living room or the room where it's allowed to go. Like add some math around that, and suddenly you know when your baby leaves like that area. When I like designed this, someone pointed out you probably don't have kids, and that is indeed true. This is how it works. We get a baby, we get a beacon, and another beacon, and we tag the baby with a board. Now, because we can see like how far away we are from a beacon, we don't know the direction. We can draw a line, another circle, and another circle, and we know that at the intersection, that is where the baby is. And it also means that whenever the baby decides to leave this area, we can sound an alarm. Now, you might think, Jan, isn't it a bit weird to like tag a baby with like a full phone? Like, why would you want to do that? Well, it actually applies to a lot of these things. Like, why would I want a juggling visualizer with my phones? You know, I don't want to like throw my phone up in the air. Then I thought, if I have a Firefox OS phone, got one here. One of these phones, like basically, is a Linux kernel, Gecko, the render engine from Mozilla, and an HTML5 UI. The UI is the only thing you see. So everything you see on the screen is rendered by HTML, CSS, and JavaScript. So that means that Gecko, the render engine, has JavaScript bindings to everything on the phone, from Bluetooth to sensors to Wi-Fi, etc. And if you strip it off, then we basically have a phone just running a render engine and some APIs. Pretty cool. So then I don't need the screen anymore because I'm not going to render any UI. So what you can do, whoa, that was hard. What you can do is get the phone. Actually, you need a screwdriver for this. The first time I did this, you can do it too, was my first screwdriver that I ever bought. You know, like 8 months later, I'm an embedded developer, so this is how life can go. So you unscrew the outer side. It's on the cheap phones, the cheap Firefox OS phones at least, easy way to screw it. Then use your screwdriver to open the case, and then you get presented with this, the phone mainboard. So what we have is a SIM card, an SD card slot, screen connector, the back camera, LED flash, and a touchscreen connector. So then I wanted to like remove this, and the camera fell out. But that learned me a valuable lesson about mobile phones. Because mobile phones have standard camera connectors. This is like a standard thing. And if you don't need the case anymore, you can just buy a new one from a Chinese manufacturer and put a better camera in your phone. Pretty cool, never heard about that. At the bottom, it depends a bit on the phone that you have. This is the place that is the antenna and has a speaker, etc. in it, so you can remove that as well. Oh no, I'm still there. So we're left with this, a print board, a camera, and an antenna. Then I took a crack because I wanted to like get the screen as well, you know, just in case, like used in a different project. The back is glued to the front, so I figured if a screwdriver can unscrew the rest of the thing, then I can do this too. So first it broke off. Then it looked like this on the front. Then I figured like this is a lost cause, so I continued with the touchscreen. So this is the touchscreen connector, and I figured if I do it like really slowly, I can get like the whole touchscreen nicely out of that. Didn't work out as well either. But I got the whole thing out. I also noticed that there was no Wi-Fi the first time I tried it. And on the inside of the cheap phones is like a little paper antenna. Just a little bit of copper plating. So you need that to attach to the board when you want to have Wi-Fi or Bluetooth or anything. And as we all know as engineers, there's nothing a little duct tape can't fix. So this is what we were presented with. A small, little chipboard, way smaller than Raspberry Pi, but a lot more powerful, including a radio chip and Bluetooth and Wi-Fi and a bunch of sensors. They can run all the demos that we saw before this. Like, really cool. So I broke the case, and then I realized I had to boot it with the battery to push it together. But it looks very cool. Like this is the banana for scale thing. You know, actually, I did the math. You can fit this little chipboard in the banana. If you want to build it into like a real device, it's also possible. You can solder some wires to the battery and put it behind. So this is like a little camera thingy that we made, built on top of a phone board. Looks pretty nice, 3D printed. Now the problem is that we have like a render engine on it, and it doesn't really do anything useful. So we wanted to like run some cool stuff on that, and we needed like a layer on top of it, and I called it Jan OS. So this started out as a joke, but it got like real traction. It got like super high on Hacker News and on Reddit, and we decided to make it to a real project. JanOS.io is the website. The slogan is "Turn your phone into an IoT board." There's builds available for a lot of Firefox OS phones, but also for the Nexus 4, Nexus 5, Galaxy S2. And it's all stuff that actual people made and sent me. And, I just can't get over the fact that I started this as like some joke, like who's going to rip apart their mobile phone, and now people actually around the world are doing it. It's fantastic. So to summarize, Jan OS is a fork of Firefox OS. It's Firefox OS, but without all the UI parts. There's builds available for mobile phones and Raspberry Pi, and all it is that you run it without a screen. You just get a super nice JavaScript API around like mobile phone features and a nice debugger, and that's what you have to do with it. So let me show you how I would make like send a text message on this thing. We first get a reference to the mobile connection. You can have multiple if you have a phone with multiple SIMs. In this case, we don't. I'm going to show you. Whenever we get a voice change event, that's the moment that we change connection to the mobile phone network. We check if we're connected. Then remove the listener. Create a new text message to a phone number and a text. And then whenever success or error happens, then we're done. So that was the whole intro. Now we're going to start with like the cool stuff. Now we're going to start with the demos. So let me first get out of here. Mirror my display. So what I have here is 2 Firefox OS phones. And I'm going to show you my Theremin demo as first. Put the sound a bit lower just in case. So these phones are connected over a WebSocket to the computer in front of here. And I'm going to take one of the phones, put them on. You get like a bit. So you don't really hear anything. No, wait. We can generate 2 different tones if 2 different phones are connected. See, now you can clap. Thank you. So the next thing that I want to show you is like use this data in like a real environment. So we want to like use the data from the phone to control something on the screen. So let me close it down and open another window. This is not going to make sound, so that's safe. So I have here a canvas, WebGL canvas. Whenever I open one of the phones, it's going to pop up there, like right away. Now I can control, if I move this phone in like the real world, it immediately changes, like based on the connection. And I can even do it with like multiple. Ta-da, here we go. So if I flip them over now, immediate. If I do this or this, there's like immediate like data that I can get back out of the phone. And you can use this to not only control this, but you can control whatever. Like one of the guys in a workshop used like data like this to create like a little pointer. Just by using the gyro and then position like a little pointer on screen. It's fantastic. You can also get like the rotation out of the phone. Like if I rotate it like this, it doesn't do it right now, but I can show you how to do it. So what we have here is like the code that powers this. And here we see like the moment that we get data out of one of the phones, we update the rotation of that cube. We can also use the alpha channel, which is the rotation like this, and then you're going to see a problem. Because even though the phones are like exactly at the same position in physical space, the sensors still give a different value, and that's because they are not calibrated out of the factory, even like the same phones. So it's kind of useless in like real life. But if we spin it around, it's pretty cool, right? So we can use this information now to do our juggling visualizer. This is my favorite part. As we all know, engineers have always duct tape with them. I'm going to use it right now because if I press the home button in the demo, then it stops recording the data. So. Some duct tape on this one. And some duct tape on this one. There we go. And now let me show you what I want to do. So here we have, let me make it a bit bigger. This is about as big as it's going to get, I'm sorry. When I now record the data from the accelerometer, you'll see that it just generates a graph. You know? When I hold it flat, just like this, if I put some pressure up, you see it, then there's some pressure down because there's like nothing happening. Now the real interesting stuff happens when I start dropping this phone. No, actually when I drop it first. So when I drop it, my safety bag, in essence what you see is that for like a little while there's like zero force applying it because gravity just pulls it down. That's essentially a g-force of 0. You're going to see what I thought at first is that like the moment until it like reaches the highest point is when it like sees acceleration, but that's not true. Because you give it like acceleration, but it still might have a velocity upwards, even though it doesn't accelerate anymore. And that's why when you throw it up in the air, you see it like reach 0 force before it starts dropping. So let me show you that. So here we have some data like coming out of the thing from 0. Now, let us start with if we do multiple phones at the same time. So now we have 2. When I do this, it's pretty easy to see which one is like up, because the z-force is higher at first and then it like drops. So now let's do some juggling. Oh man. Actually, the first time I did this, I was in a hotel in Bangladesh, and I was like standing on my bed, just like in case the phone's dropped. I'm a bit more confident now. Yes! Okay, so that was that. Let me go to the, so to prove that if you break the little chipboard out of your phone, you can still like get this kind of data. Let me open the Firefox OS, the Firefox developer tools. So I got a little chipboard here, broken out of its case. This used to be a mobile phone. Unfortunately, I can't get this bigger, I think. I can. But this is about as big as it gets, I'm sorry. So when I connect to the phone, I have like a normal Firefox developer tools. And I can just read data from the device motion sensor, accelerometer. And you can see it's like stable at 9. When I start moving it around, even here you get like this kind of data. Or when I just flip it over, like suddenly we get negative values out of this. So you're not bound to just a phone, you know? Rip your phone apart and do like this with it. So to prove that, I have the little device that I have here. It's this board with some battery soldered to it, so it also works without a wire. And when I plug that in, I hope the battery didn't run out before I did this thing. So I can connect here. At this point, I'm connected on Wi-Fi. I'm a bit sorry that it can't get bigger, but that's the beamer. So I'm connected to Wi-Fi, the same Wi-Fi network as I have here. And when I go to the same page where I did like the juggling, And now I start the juggling demo. I now get data like from this device. So when I throw this in the air, I suddenly have a phone that I turned into like a 3D printed thing, and now I can like juggle with like real balls or with like just stuff that I 3D printed. You know, this is not just for your average mobile phone. You can actually start hacking and breaking phones and like building like the demos that we see today with that. It's fucking fantastic. Okay, so before we go to like the real cool stuff, let me demonstrate how like sending a text message on this thing works. So I plug it into my computer. This one has the case because like for certain stuff like radio, you really need the battery. So I'll plug this in. I'm connected. It's on. As we can see, the SIM card status personalization ready. It's now connected to the voice network, and now we can do some fun stuff with that. So I got my own mobile phone here, and now I can just say, and I can go. It's essentially just JavaScript, as we're gonna see here. So you can write your code right here. And in this case, I want to say navigator.mos mobile message. Send. Now I need to sneak peek, and that's a bit stupid. Send. Then I plug in my own phone number. Please only call me if you're a nice German lady. And let's say. So this is like a promise-like object. And on success, I can say. And on error, I can say something else. Whatever. So the idea is that now that I'm connected, I have proper like flashing tools available. So what I can do now is go into my repository. What I can see is that it's connected, and now I can run make reset phone to flash the new firmware software on top of the phone. So here we go, we're done. It's a couple of seconds, like the development time. In a couple of like 10 seconds or something, it will buzz twice, and then I can connect a debugger to it as well. So let's hope that that happens. If you like feel adventurous, you can always like look at the logs. Shouldn't have put the battery. So this is the beautiful thing about live demos with hardware. Sometimes it doesn't work. So let's pretend that this thing now booted. And what is that? I just got a notification on my phone. It's amazing, I got a text, yay. Yes, thank you. Good. Anyway, now the downside is that, like, the next thing that I was going to do with this thing is like show that because we have like a hyperlocal service running here, right? The beer service, tweet for beer. So I wanted to show you that by just running a JavaScript command, I was able to get a beer. So now just hint to the guy that was supposed to do that, and we're going to pretend that that actually happened as well while I'm talking. So yeah, I just pressed the button, and now like a beer is supposed to come. It's the future. And while they're doing that, I'm gonna open the music stuff. Hey, yeah, it works! Hooray! Deutschland. So the idea is that I have a music generating algorithm living in my computer, and it's running here. So at this moment, it just generates some music. Now I'm going to take my phone. This can be all of you in the audience, and I'm going to go to a web page. I'm going to go to a web page, and on that web page, essentially what it does is just gather the data from my phone and sends it over. So what I have here now on the big screen is my device, and the depends on like the values that my phone gets. So if I move it here, you hear the music changing. And make it clean again. Now, of course, this is a bit boring because there's no visuals here. So let me. So now we have visuals as well, all fed from like the same data. Because as you can see, when I move to the left, the music gets like a bit boring. Or if I move to the right, it gets like rich, and the bars reflect that. Also, I can control the beats per minute on this music. So this way it gets slower. Or this way it gets like faster, more intense. Now, then I thought these are cool visuals, but let's like take it one step further. Should have seen that coming by now. What if we can also have a GIF playing at the same rate as the beats per minute and have like a guy dancing on stage? So I created a little thing, and it's on GitHub. It's a GIF player that extracts all the frames out of a GIF and then updates it like at a certain pace. So I'm gonna put that here. So, and this guy, depending on like how fast the music goes, he like intensifies his dancing. So maybe we can like bind it to the sound system during the during the beer garden. Good. Okay, last demo that we're gonna show today, and that's the baby monitor. So for that, I'm first gonna distribute these beacons and make like a field where the baby is allowed to go. Sorry if the camera can't follow me anymore. So I put one here, and let's say that our baby can have 5 meters of like space. 1, 2, 3, 4, 5. And oh, now it's gonna echo a lot. Sorry. Let me think how I calculated that again. Oh, yeah. So here we put 1, and then we're gonna take 5 steps here as well. 1, 2, 3, 4, 5. And we need a receiving device, and that's gonna be one of the phones. Let me remove the duct tape. So this device I'm going to put like next to one of the beacons. And now I'm going to show you my UI. So what we have here, let me make it a bit smaller. So we get like the data from, for example, every of these beacons and like plot it right here. The thing is that it really differs at the moment, and that's because the RSSI, the value that you get, like really differs over time, and that's why you see like growing and shrinking all the time. So what we can do is like buffer it. Then we get like a bit more sane values. As you can see, like blueberry now makes sense because it's like actually close to the blue beacon there. And the mint one here gets smaller as well. So the moment that we do that, we can like draw some intersections. And based on that, we know that like in that triangle, that's where our baby is located. It's a bit off. The thing is, you need calibration for that, and like with like a lot of people in the audience, might go a bit weird. So let me put the average, and this is like the position where the baby should be. It's like fairly accurate, actually, if you think about it. You know, it's like almost at the ice dot. So when I move it, to like someone here in the center, like you, for example. Let's hold it. We'll see that over time, and that's because we do the buffering. It takes a little while. We see that the dot will move to like the actual location. As you can see, it moves like into the field, and it's like a 20-second delay or something. And now we're actually at a pretty fairly accurate position because it's like sitting like right next to the blueberry one. Now we can use this, and I can get it back, to detect like when the baby escapes like this zone. So let's say that I'm going all the way here. And as you can see now, the dot is like all the way out of the thing. This is the moment that we should do an alarm. So for that, I thought, like, why would you do an ordinary alarm if it just like made a music generating algorithm? Let me put the phone here. Then go into the baby project. And we're going to use the data coming from the sensors to generate some music in the same way as we did with the phones. So the thing is, it should be like quite relaxed. Can you hold it again? You were a good holder. So, you know, it's kind of relaxed or whatever. It's just like sitting here as a baby. But now, what happens if the baby escapes? See, music intensifies, and we get like a warning, like your baby is completely out of whack. So, okay, you heard it intensify for like a little moment. You know, it's like a tech demo. So here, you know, different music, like completely, this is baby-generated music, guys. That was intense. Good. All right, so that was like all the demos that I had today. You know, today what I hope that you've seen is that we're in the future already. Like all this is based on technology that's available today. Normal JavaScript stuff that's available today. Little beacons that you can buy for $10 each now, anywhere. So for you, there's no excuse anymore. You know, start hacking. For me, like playing with hardware, it's like the same feeling as when I started programming and just like, what is your name? Jan. Hello, Jan. You know, that is what I get back with hardware. You know, I wave my hand in front of a sensor and I get an event. That excites me. So use that sensor data, like think outside of the box. Or if you want to break your phone, buy a ZTE OpenC. It's available on eBay here in Germany for $60. And, you know, break it. You know, start hacking, you know, do some cool stuff and like make me proud. And with that, I want to thank you all. We have 5 minutes for questions, but let me say that if you have any questions or long questions, whatever, I'll be around all afternoon, so just catch me in the beer garden and that will be fine as well. Just, if someone can get my beacon and like throw it to me. Everyone wants to drink beer, yeah, I understand that too.
Who's buying a phone to break it now? Come on.
Yes, oh man. Sales just doubled in Germany.
Would you be able to build a system that if you throw the phone in the air, tweet for a beer?
That would be like totally possible. Actually, that was the premise, like kinda, of the Node Rockets project. It's a little thing we do with JSConf, where you get a Raspberry Pi, you put it in like a bottle, you use then water power to like fly it up in the air, and then you have like some sensor data that you can read with Node.js. And the idea is that whenever it's at the highest point, you do an action. For example, like opening a servo, and then that's bound to the parachute. That's a theory. We built that. It totally failed. The parachute did not deploy, and the rocket crashed so hard with 100 miles per hour that even the SD card that holds the operating system was non-functional anymore. Yeah. But yeah, nice idea.
I think we got a question.
Okay, I've got a question. Is it available on Are those JavaScript APIs and sensors data and so on available only on Firefox OS or on any mobile browser?
So, except for the Bluetooth one, everything is available on Chrome on Android and Firefox on Android, and most of it also on Safari for Android. So this is stuff you can use today, except for Bluetooth stuff.
Okay, thanks.
Okay, second question. Second question over here. First of all, this was awesome.
Thank you.
Second, what I didn't really catch is why to implement all those stuff in a language like JavaScript when I can possibly implement it in a language as C, which communicates on a lower level with all the sensors, and could be in certain points more effective on calculations on the accelerometer or stuff like that. So I didn't really get the pros and cons of it.
I mean, it's very true what you say there. The thing is that if you're a hobbyist developer today, and you want to have, because at least what you need is an Arduino to write some C against, and at least a GSM shield and some sensors. The Arduino will set you back 40 euros, 30 euros. Your GSM shield will set you back 80 euros, and then some sensors 20. So the whole package will cost you 130, 140 euros just to get started. While I can get like this phone in India for 30 that can do exactly the same. So it's like a nice cost-effective way, and you have a lot more power. And the whole web. Like if you want to have a WebRTC stream while you're juggling, like totally possible. It's fantastic. So for prototyping, it's amazing. For if you want to do like real stuff, like MCU development or stuff, I mean, I do it for a living. Don't go this route, please.
So thank you.
Should we keep it like that and send people home to get beer?
Sure.
Or to the beer garden?
We have 3. Thanks first for the talk, Jan.
Yes. Thank you. Thank you.